everybody. This is our first video for Unit 3. Right now we're looking at our introduction to oxidation and reduction. We were assigned 5 practice problems. I'm going to demonstrate each of these practice problems, or at least begin the demonstration of each of these practice problems, and hopefully walk you guys through the process. All right. Question number 1A. All right, so in this question, we need to identify each of the following changes as either being oxidation or reduction. So in this case, iodine is gaining 2 electrons to become iodide. So electrons as a reactant means electrons are gained. So let's make a couple quick notes here. All right, so the gain of electrons is reduction, the loss of electrons is oxidation. There's a cute little mnemonic to help us remember these two. Leo the lion says grr. Leo says grr. All right, so now in this scenario, let's go back and look. Here we are gaining electrons. We're gaining electrons in this process, so that means this is a reduction. All right, let's take a look now at practice problem number 2. All right, in this scenario, we need to be able to look at each part of the reaction and make an inference about what's going on. So in the case of bromide becoming bromine, we have a negatively charged particle becoming neutrally charged. It's losing electrons. Therefore, if you lose electrons, you're oxidation, Leo. Cl2 gains electrons to become chloride. So here we see the charge, no charge, neutral, becomes a negative charge. So Cl2 has to gain electrons to become a chloride. Therefore, this is reduction. We call this the oxidation number. So if you move to the left on the number line, you're being reduced. So when we go from 0 to a negative charge, it's reduction. When we move to the right on a number line, we become more positive, such as a -1 to a 0. That would be oxidation. All right, let's take a look at question number 3. Something we're going to have to remember here is that this is an ionic compound that's comprised of an Mg2+ ion and an iodide, I1- ion. So in this scenario, magnesium will lose electrons. So Mg is oxidized. It loses electrons to become Mg2+. We also see that I2 is reduced because I2 becomes iodide, a negative charge. It gains a negative charge, meaning it is reduced. If you gain electrons, you're reduced. Grr, right? Let's make a few quick notes here about oxidizing agents. So oxidizing agents will oxidize other compounds. They are reduced in the process. A reducing agent is a chemical species that will reduce other compounds. Let's go back now for a moment. If Mg is oxidized, that means Mg is a reducing agent. And I2 is an oxidizing. I'll get the hang of this machine soon enough. All right, let's take a look at question number 4 now. Question number 4, we're asked to identify the oxidation number of the highlighted or bolded element. In this case, it's the chlorine. Now, one way to simplify this process is to divide it into its component ions. So here we have an Na plus and a ClO4 1 minus. If we review our rules of assigning oxidation numbers, the more electronegative element of the two, oxygen and chlorine, in this scenario, because we're trying to solve for chlorine, takes its preferred negative charge. If we refer to a table of common electronegativities, we find that oxygen is more electronegative than chlorine. So that means that the charge of chlorine plus 4 times the charge of oxygen, because there's 4 oxygen, has to add up to a -1. That is to say, the charge of the polyatomic ion. If the charge of chlorine is our unknown that we're solving for, but the charge of oxygen is known, -1, the most electronegative element, takes its preferred charge. Charge in chlorine is equal to +7. No wonder this is such a good oxidizing agent. Chlorine, a very electronegative element in its own right, is electron starved from being part of this polyatomic ion with oxygen. Perchlorate is a strong oxidizer. This chlorine will steal electrons from other compounds readily, which means that things that don't normally combust become extremely combustible. All right, let's take a look at question number 5. All right, in question number 5, we're looking to determine the oxidation number of the boldface element, and the following formulas are ions. In this case, we're looking for the charge of nitrogen in NH4+. Now, hydrogen's tricky. It only has 1 electron to gain or 1 electron to lose. So we always have to make sure that the math works. We don't want to get caught making an error. Hydrogen only has 1 electron to give, so remember that. In this case, the charge of nitrogen plus 4 times the charge of hydrogen has to add up to a +1. Now, in this case, the most electronegative element is nitrogen. It would take its preferred oxidation number, if we refer to our table of common ions, a charge of -3. Do a little bit of math, 3 to both sides. This works. Again, we just want to make sure our math works. The charge on our nitrogen atom is a -3. All right. Good luck on the rest of your practice problems and assessments. I look forward to reviewing your work.